All right, let's look at this again. We said that this was at 5. This was at 7, 9, 11, and 13, okay? Our rate we know, we already calculated was 2. It's increasing by 2, and we can see that here. What we can do is, well, if I change the input by 1, how much does the output change? Okay, remember we said m is equal to rise. Now rise is the up and down, so that's referring to the change in the y values, right? So the rise is how much does it up and down? That's the change in the y value, the increase in the y value. That's here. So we've got the x value here and the y value here. And then the run, that's the change in the x value. The run is the change in the x value, right? So that's the x value. So what I could do is, to find the slope, I could pick a couple places. So I could pick a place, let's pick this point here. And it doesn't matter, I can choose any other point, any other situation here. Maybe I'll choose this one here. And I'm just going to look at what the change in the y values are. And then what is the change in the x value? So m is equal to, well, we go from 5 to 11. That's a positive change by how many? That's 6, right? And then in the run, or the x value, we've gone from 2 to 5. So that's a positive change as well, a positive 3. And then we get our slope, m is equal to, that simplifies to 2, which is the same as what we had determined previously. Okay, so we're looking for rise over run is the same thing, but now we're looking at it as, what's the change in the y value? Oh, and what's the change in the x value? Okay. All right, so we're looking at a graph that we already looked at before. We already did this slope using the graph. Okay, we counted starting with the left point, and we could choose any point on here. We could choose, as long as it's at an exact point. There probably are other points that we can choose. So what is the change in the y value? Okay, that's the rise, and the change over the change in the x value. If we're starting from this, doesn't matter which point I start from, but this is labeled x1, y1. This is labeled x2, y2. It doesn't really matter where we're starting from, but we want to find the change in those values, okay? So as a habit, it might be a good idea, the one that's to the right, that could be your x1, y1, and the one that's to the left could be your x2, y2. Doesn't really matter, okay? So I want to go and determine what is the change, the slope. We take the first y value and subtract it from the second y value. Now, we kind of did that earlier in the previous table. We kind of did it mentally, but now we're going to just do it with the coordinates. So that first y value was 5, okay? So 5 minus the second y value here is 0. Over, now we're going to look at the change in the x values, the run. So the first value is 4 minus, and the other value is 1. And that is equal to 5 over 3. So again, the same slope, different ways. I would say that if it's graphed and you can clearly see the coordinates, it's easier to just go ahead and count the rise and the run. But sometimes, and I'll show you an example in a second here, we don't even have a graph. We only have the coordinates. And if we don't want to go and make the graph, we can actually just use this formula for slope, for the change in y's over the change in x. All right, so we were looking at this question earlier, and we used the graph to determine what the slope of the line is, okay? What we're gonna do is, you know what, I'm gonna label this one x1, y1. I need to establish that first, right? And I'm gonna label this one x2, y2. So then I can keep my things in order. And the formula is y1 minus y2. That's the change in the y values, the rise, right? And then I'm going to have x1 minus x2. That's the change in the x values, the run. Okay, so what do we have? We're going to have 0 minus, and we have minus 2. So 0 minus 2, and then for the x1, negative 1 minus negative 5. Okay, let's simplify that. So 0 minus 2 is negative 2. Now, this is tricky. Negative 1 minus a negative 5. When we subtract a negative, we're actually adding, right? So that's going to be negative 1 plus 5, or 4. And we know this simplifies to negative 1/2. So we use the coordinates. We had the option there to use the graph. Let's look at one where we don't have the option, we just don't have the graph. All right, so here's a question, and I'm not going to answer the question, but I do want to find the slope. This is a little bit more advanced than what we are ready for at the moment. But in this question, we need to find out what the slope is first, that rate of change, and we're not given a graph. But we are given some coordinates here, okay? So what I want to do first is, it doesn't really matter how I do that, but I'm going to label this one x1, y1. So that's my first coordinate, my second. And it wouldn't matter if I switched to x2, y2. So I've established that, okay? And remember, our slope is equal to the change in the y, the rise. The rise is the y value, and the run, the change in the x value, okay? So, and that is equal to y1 minus y2. That's how I get the difference between the two y values. And then x1 minus x2. So let's just apply that, and if it's a fraction that needs to be simplified, we'll do that. All right, so y1 is 7 minus, now what is y2? Negative 5. There we have it. We're subtracting a negative again, right? And then x1 is negative 3 minus 6. That's y2, or x2, sorry. So when we simplify this, 7 minus a negative 5, that's adding 5. So we have 12. And then this is going to be negative 3, and we subtract 3 more, we have negative 9. We can simplify this fraction. Common factor here is 3, right? So we divide 12 by 3, we have 4. And 9 divided by 3 is 3. 4/3. So the slope is negative 4/3. Okay? So that's what we need to do. We need to establish what is x1, y1, what is x2, y2. Set up our formula. Okay, so write this in your notebook. Keep it there. And always knowing that, well, if I have a graph, I can just count it out. But if I don't really want to graph this. I have to set up a graph, and first of all, I need to make sure it's really accurate, and then go and count the rise and the run. I can actually just calculate the difference in the y, which is the rise, divided by the difference in the x's, which is that's the run, right? All right, so go ahead and work through the next IXL activity until you get to about 80% or more, and then you're ready.